All right, so we're just rolling along at this point. So I've been recording videos on a decently regular basis now for a full exam review for grade 11. So I'm going to try to do this or continue to do this on a regular basis. And hopefully this becomes a thing where I do a video daily. That would be my dream. That would be my hope. Um, so, continuing along, this is, I guess, part 4, because I'm basically doing a video a page, and I'm trying to slow down the explanations here. So, let's do this. So, I got 12a, and I'm dealing with right triangles, and I'm going to solve for the unknowns in the diagram just as it explains. And I have to express the answer to the nearest tenth. What I'll do is I'll basically set this up for you, the viewer, and then if you want to calculate the answer using a calculator, you are free to do so. So if I may, let's see, boom. Boom. Okay. That's as decent I'm going to get for an actual right angle triangle. Okay. I got x, and by the way, it's right angle because that is 90 degrees, just if you didn't know. And then I've got 12 meters over here, and I've got 40 degrees. Now, this is probably taught to you in, grade 10? But there's this thing called Sohcahtoa. Now, in Sohcahtoa, it's kind of like a cheat, and it's basically telling you to use a certain trig ratio with a certain ratio defined, right? So, for example, sine, represented by s, is calculated by doing opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, it's doing that, it's saying these terms, opposite, adjacent, hypotenuse, relative to an angle, right? Now, generally in an equation, you need one unknown and two determined numbers in order to two determined quantities in order to find the unknown, right? So, for example, here I'll have an angle defined as well as a side length, and now I can find the missing side length. Now I need a way to relate these three quantities together, and obviously that comes with, sine, cosine, and tan. So let's do that here. So I got an angle, right? And basically what you have to do is you have to write the ratio, name, and the angle, right? So for example, here I would have a hypotenuse defined, as well as relative to the 40 degrees, that would be the opposite because it's furthest away, right? This would be the adjacent side. So I'm dealing with opposite and hypotenuse. I'm dealing with sine. So I go sine 40 degrees equals opposite, which is the x quantity, the variable that I'm trying to answer, divided by the hypotenuse quantity. So if I isolate for x, which is obviously the goal because that's what you want to find, right now I'm dividing by 12, right? So to undo that, I have to multiply both sides by 12, and I place a dot to symbolize the multiplication. I try to avoid putting an x because that confuses people with that x quantity. So just put a dot. Who cares, right? So I get 12 sine 40, and that's my x. Punch that into a calculator, and depending on what your calculator is, sometimes you have to do 40 first, then hit sine, then multiply by 12, or you could actually just write 12 sine 40 and it'll compute it for you. Make sure that it is in degrees though, not in radians. That's important. Next, this triangle is not a right angle triangle, obviously because there is no 90-degree angle here. Now, in grade 11, in the 11th grade mathematics course, you are generally taught about this cosine law. And that's generally what you use if you don't have a right angle triangle. So that's what we're going to have to use here. Now, the cosine law says that if you've got an angle, which is now y, remember x was the side length in the previous question. Now it's an angle. And it's contained, if the angle is contained between two side lengths, then I can use that to hopefully find y. But in order to do that, I would also need this guy, the opposing side length. Now, just for argument's sake, let's call this capital Y. Okay. Generally, the convention is to label the angle by the capital and the side length by lowercase. But let's just go with it. Who cares? Okay. So here's how cosine law would work. I would basically write the opposing side length squared equals 23 squared plus 14 squared minus 2 times 14 times 23 times cosine y. Now, I have two unknowns in a single equation. This isn't going to work. I need two unknowns, two equations. How can I set up the second equation? Well, there's also sine law, right? So I can use sine law. So I can go sine 55 over, and this is how sine law works. You hit sine 55 divided by the opposing side length, 23, equals to sine y over y. Now I have an equation set up. Okay, now this is going to need a little bit of work now that I'm looking at this. This is interesting because I've never seen a high school level course do this. So this is very good. This gets you to think. Okay, so I will have to, I will have to isolate for one of the variables and solve for the other. Now, obviously, I want to find lowercase y. So I will isolate for capital Y, plug it into the first equation, and then solve for lowercase y. So let's do that. So now this is going to be kind of confusing. But when I have an equation, I can reciprocate both sides of the equation. You'll see why that's important. It's going to make life a little bit easier. So I'm going to do that. I'm going to go 23 over sine 55 equals capital Y over sine y. And now I can easily isolate. Usually what students do is they do like a cross multiplication and then isolate that way. That adds an extra step. Really, this is a simpler step, right, than doing cross multiplication. This is basically just flipping both sides. You can do that so long as you do it to both sides, right? Now, if I now multiply both sides by sine y, then I have isolated for capital Y. Capital Y is going to be 23 sine y over sine 55. Okay. Now I can plug that term, this term, into here, as long as I square it. That's it. So 23 sine y over sine 55 squared equals 23 squared plus 14 squared minus 2. 14, 23, and cosine y. Now, this also, now that I'm looking at it, this looks like I will need some identities. And I'll show you why. This will be a quadratic in cosine y or sine y, depending on how I want to go about this, but probably cosine y because that's simpler. This is going to be a mess. So 23, let's square this. 23 sine squared y over sine squared 55. Now, what I'm going to do is I'm going to replace sine squared y by 1 minus cosine squared y, provided I do a parentheses. Why would I want to do that, though? The reason why I want to do that is because I just want to uniform. I want to make everything uniform in this equation. Sine y is different than cosine y generally, right? So if I make sine y into a form of cosine y, then I've just got cosine y. It's kind of like having a single variable, right? I could call cosine y z, and now I've got a quadratic equation. So I'll show you. So 23 squared over sine squared 55 is a constant, right? You can punch it in your calculator, you get a number. Minus 23 squared over sine squared 55, that serves as a coefficient for the variable cosine squared y, equals to this additive sum, okay, minus this coefficient, cosine y. Okay. Now hopefully you're not totally lost right now. Let's go on to the next page. Boom. Now I could tell that I've lost some numbers here. This is 23 squared. Okay. Cosine y. There's a bracket there. Okay, I don't know why it's doing that. That's kind of weird, but yeah. So now let z equals cosine y, right? That simplifies things for me. Okay, I get 23 squared over sine squared 55. Again, punch this into your calculator, forget what the number is. Minus 23 squared over sine squared 55. Cosine, oh, now I'm switching the variable, right? This is called a change of variables. So now this is z squared equals to this number, punch that into your calculator, whatever that is, okay, minus 2 times 14 times 23, punch that into your calculator, and I got z. Now I've got basically a constant right there, a squared term, or an a term right there, and I've got a b term right there. So these two guys, these two constants, become c, right? And then this guy becomes a. And then this guy becomes b. Now I can solve for this quadratic using any sort of quadratic solver, or you could use the quadratic formula, and then you can solve for z. So once you solve for z, that's equal to cosine y. Then you do inverse cos in your calculator, and you get y. And that's it. That's basically how you solve that problem. Now, that was a mouthful. I was surprised by that. Good on the producer of these questions, though, honestly. So sketch one cycle or period of blah. So y equals cosine of 3x plus 2, showing all critical points. Now there are certain points on the cosine function that are extremely important. So the original cosine function, okay, maximizes at an angle of 0 degrees or 0 radians, whichever. Okay, it goes all the way down to 0 at pi over 2 or 90 degrees. Then it goes to -1 at pi. It goes up back to 0 at 3 pi over 2, and then it maximizes at 1 at 2 pi. So you get this, behavior. Now, what does that 3x do? What does this 3 do? It's a part of the transformations, right? So that 3 basically, it does a horizontal compression by a factor of a third. What that means is, mathematically anyway, I can change all of these x coordinates, all these x values, to a third of what they are. So instead of pi over 2, it'll be pi over 6. I'm just dividing everything by 3. Instead of pi, it'll be pi over 3. Instead of 3 pi over 2, it'll be 3 pi over 6, which is just pi over 2. And instead of 2 pi, it's 2 pi over 3, and that's still a full cycle. It's just the period's different. Now, what does the plus 2 do over here? Now, that's a vertical shift up by 2 units. So all you have to do is draw every point just 2 units up. That's it. That's basically what you have to do. Oops, that's 1 unit up. Okay, if I make that 2 units, that's fine. So yeah. So the general shape of the curve hasn't really changed. It's just been shifted up. That's it. Boom. Okay? So that's that. Next page. So we got y equals 2 sine of theta. Now theta and x, or whatever angle letter you're using, it doesn't matter. It means the same thing. Now state the amplitude. The amplitude is generally the number in front. So amplitude equals 2. Okay. Period. How do I get the period? Well, I got to look at a multiple in here, the k factor. Now the k factor in the last question was 3. If there is no number present, it's basically 1, right? So k equals 1. Now there's an equation for period. Period, okay, is going to be 2 pi, or 360, over 1. So, over k, excuse me. Now, but k is 1, so this is going to be 2 pi over 1. 2 pi over 1 is 2 pi. So the period is going to be 360 degrees, or 2 pi. Phase shift. Phase shift is located here. So the phase shift, in this case, usually we call it phi. You might be calling it something else. Maybe not a, one of those letters, but maybe D or C or something. Phi is generally the angle that's phase shifted. Now, I can't remember if you include the negative or not, but let's just say in this case it's 150. Okay. I think it is. Now this is 150 to the right. Okay. Maybe I'll just do that. So I don't have to necessarily include any sign. I just say to the direction, right? So minus means to the right. Vertical shift, that's a constant attached. Now there is no constant attached, so it's basically plus 0, so no vertical shift. Now for B, things are a little different. Now I've got a minus here. I got a negative in front of the cosine. Does that mean that the amplitude is -1? The reason why I say 1 is because there's no number. Now, is it -1 or is it just 1? Now, the answer is amplitude is always positive. So amplitude is 1. It's just a number that illustrates how wide it is this way. So a negative has no meaning there. Period is still going to be 2 pi because k is still 1, right? So that multiple is still 1. So there you go. Now I'm being selfish. I'm being stupid here because I'm switching between radians and degrees where I shouldn't be, right? Sometimes you're using degrees, sometimes using radians. Don't do that. Let's just say 360 is the period. Phase shift phi is going to be 45 degrees to the left. Okay, and the vertical shift of 1 up. Okay, up because there's a plus. Notice that for doing horizontal shifts or phase shifts, it's not what you think it is. Like a plus in phase shifts is actually the opposite to what you think it is. I would say right, but it's actually left. Whereas if you're doing vertical shifts, it is exactly what you think it is. It is up. if it's plus, down if it's negative. Anyways, that covers this video. Thank you so much. Hopefully it's not too bad. And I'll see you in the next video for part, I guess, 5. All right, peace.